let's install Docker on Windows 11. We start by opening the Windows terminal, and here we need to install Windows Subsystem for Linux, or WSL. WSL is a prerequisite for Docker, so let's start with it. To install WSL, simply run WSL --install. I already have WSL installed, but if you don't, this command will install it. Installing WSL only takes a few minutes, but it does require a restart of the computer. Once we're done with the installation of WSL, we can move on to the installation of Docker itself. Let's go to docs.docker.com, and here we choose Get Docker. As you can see, Docker Desktop is available for Mac, Windows and Linux, and in this tutorial we will be focusing on the Windows version. We click here to download the installer, and the installer was downloaded. Let's click to run it. Docker is now being installed. It will take a few minutes. Once it's done, we need to click on Close and Restart, which will restart the computer again. Okay, the computer was restarted, and after a minute or so, this window shows up where we need to accept the Docker agreement. We can then log into our Docker account, but this is not mandatory and we can continue without signing in. Here we can fill in a few details about ourselves and the way we intend to use Docker, and once again I'll skip. And the Docker engine is starting. This shouldn't take more than 2 minutes or so. Once it loads, we get to see Docker's main screen. From here we can see our containers and our images. Docker images are templates. Think of it like a very minimalistic operating system with only one specific application pre-installed. Containers are specific instances of these images, so they are the actual things that run Dockerized applications. Let's, for example, look for Ubuntu. And we get many results, the top one being the official Ubuntu image. Let's pull this image to download it to our computer, so we will be able to create containers from it. And the image was pulled, and if we now get back to the Images tab, we can see the Ubuntu image. By clicking on the Play button, we can run a container of this image, and under Optional Settings, we can configure the new container. Then we click on Run to create the container and run it. So the container was created and run, but since it didn't have any job to do, it immediately closed. If we want to interact with our Ubuntu container, we can open the Windows terminal again, then run docker run. Then I add the -it flag so that we will get access to the container and be able to interact with it. And the container was created, and we now have a minimal instance of Ubuntu that's running right on our computer and is a fully functional Linux system. So we can, for example, run a command like ls to list our files. And if we want to update the package list, we can run apt update. Once the update is done, we can install something like Nano, a minimal text editor for Linux. Then we can use Nano to create a new text file. At any time we can type exit to close the container and get back to Windows. Let's see another example of an image, specifically the Apache image. So let's look for Apache, and its image is actually called HTTPD. Once again, the top result is the official image, and let's pull this image. And we can now create containers of this image. To be able to access the port used by Apache, we need to expose it, which is done by a technique called port forwarding. So let's click on Optional Settings, and we want to map a port in our host machine to port 80 in the container. As an example, I'll map port 8080. Let's run the new container. And if we now click on Containers, we can see that the Apache container is currently running, and that port 8080 on the host is mapped to it. So let's open a web browser and navigate to this port on localhost, and we can see the reply from the Apache web server that's running inside our container.